welcome to another tutorial video. In this tutorial video I'm going to be going through parts 2.1 and 2.2 of this exam question. Part 2.1 asks us what is the binary equivalent of the decimal number 102. Now there are two different ways that you could approach this. One is to do a table of decimal values across the top and your binary values across the bottom, which I think is possibly the easier way of doing this part, as it's only for 1 mark. So let's go through that one first. So I've written out my table of powers of 2 across the top then, and if you've watched some of my videos on binary I go through this in a bit more detail. But what I'm going to do for this one then is I need to fill in my table. So 128 is greater than 102, so I'm going to put a 0 there. 64 is less than 102, so I'm going to put a 1 there. And if we add 32 to 64, we get 96, so I'm going to put a 1 there. And we've got 6 left after we've subtracted 96 from 102, so I'm going to put a 0 there and a 0 there. And 4 plus 2 makes 6, so I'm going to put a 1 there and a 1 there and a 0 in there. So from our first method then, our binary value is 0, 1, 1, 0, 0, 1, 1, 0. There is another way you can do this, and that's called base division. And what I do with base division then is I write my binary number out like so, and then do the bus shelter method and put and divide this, and I want to find out the remainder from each division. So first of all then, I'm going to divide 102 by the base, which is 2. And I get 51. And the remainder there is, of course, 0. And then what I do is take my result here and divide it by the base again. So I divide 51 by 2, and I get 25. And the remainder there is 1. And I continue to do this until I reach 0. So I'm going to continue dividing my result by the base, and I've reached a result of 0, so I stop there. And now to get my binary number, all I do is write out the remainders from bottom to top. So I do 1, 1, 0, 0, 1, 1, 0, and if I make this an 8-bit binary value, you can see that I've got the same number that I got using method 1. So for my answer then, I would obviously need to show this working in the space for the question on the exam. But for my answer in this case, I'm just going to write in my binary value. Okay, that's how you answer part 2.1. So for part 2.2 then, there's again 2 ways that we can do this. The first way is that I'm going to convert 87 to binary and then convert it to hexadecimal. So the way I do that then is write out 87 first, write out my table. Then I'm going to fill in my table for the numbers that make up 87. So that's going to be 0, 1, 0, 1, 0, 1, 1, 1. Because if you add 64, 16, 4, 2 and 1 together, you will get 87. What I then do is take this part of the binary number, so the leftmost 4 bits, and use that as a 4-bit nibble over here, and convert that into a decimal number. And I then take the other 4-bit nibble and convert that into a decimal number as well. and then we take the hexadecimal equivalents of both of these numbers, and for 5 and 7 that's just going to be the same, 5 and 7. Now you can use base division to do this as well, and this is slightly quicker because we're dividing by 16 this time. It's quite a quick method, base division, for converting to hexadecimal. So first of all, what I do for base division then is write down my 87 divided by 16, and if I do that I get 5 and a remainder of 7, and if I divide 5 by 16 I get 0 with a remainder of 5. And if we write down our number in from bottom to top, we get the same result, 57. Okay, so that's my answer, 57. Okay, that's the end of this tutorial video. Thanks for watching.